island parameter problem, number 463 on LeetCode. It's very popular, and the problem statement is you're given row times column grid representing a map where grid I, j is equal to 1, and that point represents land, and if grid ij is equal to 0, that represents water. Grid cells are connected horizontally, vertically, but not diagonally. The grid is completely surrounded by water, and there is exactly one island, i.e., one or more connected land cells. The land doesn't have lakes, meaning the water inside isn't connected to the water around the island. One cell is a square with side length 1. The grid is rectangular, width and height don't exceed 100, and determine the perimeter of the island once found. So um, let's go to the whiteboard to explain how we would approach this problem. Okay, so let's go through an approach to solve this problem. So let us restate the problem statement. Given a grid, find the one island, and then find the perimeter of the island. Very quickly, let's name a few constraints and definitions. The perimeter is basically, think of a box. The perimeter would basically be the length of all of its edges. So yeah, P equal to length of edges slash outer edges. And also, there's only one island, so that's something we should keep note. One island. The grid is represented in zeros and ones, where 0 is water and 1 is land. So since there's only going to be one island, when we find the first one, the rest of the island is going to be adjacent to that block. And what else do we have to keep track of? Yeah. Okay, give me a second to collect my thoughts. P1. Oh, also, this land, a valid land / island is going to be an island where all the ones are adjacent in 4 directions. So we're going to only check for land that's left, right, up, or down, but we're not going to go traverse diagonally. So yeah, so 4 directions land. Okay, so in input and outputs, what's something we could be given, and what should we expect from our solution? So an example is if we're given a graph that looks like this. So let me just create a simple graph here. 1, 2, well, not a graph, it's more like a grid. 3, 4. In this case, have our island be here. Everything else is going to be zeros. And what we want to calculate is the perimeter of this island over here. And the perimeter would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So input is this, our output would be 12. Okay. So let's find a few things that we note / observe from this problem that we're given and the input that we used. So first of all, in addition to all of this, when we are calculating the perimeter, we can't just find a block that has 1 and add 4 edges and say, hey, that's going to be part of our perimeter. Because in this case here, if we found this first one here and we added 4, there are 3 edges that we can add to the perimeter, but this 4th edge is not going to be part of the perimeter because it's going to be part of another graph here, and the perimeter is counting the outer portion of the entire island, not like anything inside. So we have to keep that in mind. Make sure we add to perimeter, I guess smartly / a valid edges. So in addition to a valid edge not being where the next island block is at, valid edges could also be where we find where if we try to traverse into it and water is in that location. So a valid edge would have 0, aka water, on the other side of the edge, I guess. Other side of edge. And also in this case here, the edge would also be if we're trying to traverse out of bounds here. So we can't find water, but we also can't find land. So it would still count as an edge. So if land edge is adjacent to out of bounds, also at an edge. So yeah, that's a good amount of observations we can make for now. What are some ways we can solve this problem? So what I thought was the brute force solution, which happened to be the solution LeetCode was widely expecting / taking, was that you just had to loop through every single item in the grid, and whenever you find a 1, you add 4 to the perimeter, but then you also subtract based on what's adjacent to that block. So yeah, that works, but that's not quite as much fun as the solution I went with, which was my solution used depth first search. And the reason why I use depth first search is because I know that as soon as we find the first instance of the island block, we don't have to keep looking for the rest of the grid for the other parts of the island blocks, because they're all adjacent to each other. So what my solution is going to do is it's going to basically loop through all the items in the grid, but as soon as we find the first instance of an island block, we run depth first search on that block, and then we travel all around finding all of the other land pieces, and we add to the perimeter based on if we found a valid edge. And a valid edge would be if we are trying to traverse to an edge, or if we are trying to traverse into the water. But it wouldn't be if we were trying to traverse through the island itself. To keep myself out of an infinite loop, and also so I don't accidentally count a visited block as a valid edge, I would color along the way all visited blocks -1 in this case. I tried 0, and that would just it would whenever I was at a block, it would mistake it as water. But yeah, anything but 0 and 1, you can color the block that were visited just to mark it as visited. So if we are at a valid edge, we just increment the perimeter, and then we break from the recursive function call. But if we try to go through, we're trying to count a -1, in that case, we just want to break from the function call itself without incrementing the perimeter. So yeah, let me just quickly write that out as an algorithm. So yeah, loop through grid when 1, aka land, is found, call DFS on it. And then at the end, after that first search is called, we want to break from this for loop, for these nested loops early, so we don't get a time exceeded error. So then return perimeter calculated. Yeah, I also noticed that when people were trying to answer this question with depth first search, a lot of people were complaining that the answer was being accepted because it took too long. But yeah, I think maybe if you returned early, you won't have to deal with that problem. And also probably forgetting to color the visited nodes as visited could also be contributing to why they were getting, seemingly it looks like it was an infinite loop they got themselves into. But yeah, loop for the array, or loop for the grid, find 1, call DFS on it. So now what are we going to do in the depth first search method? So on DFS, what you want to do is you want to check if we are out of bounds. If we are, increment perimeter and break from method. We also want to check separately if we landed on a water block. We don't want to check it along with this check here, because if we are out of bounds, but we also happen to check if we are out of bounds,
it will throw an index out of bounds error. So we want to check separately. Check if we are at water, and if that's the case, we increment perimeter, and again break from method / recursive calls. Finally, we want to check if we are at a visitor block. And if that's the case, we don't increment to the perimeter, but we do break from the method. So break from method. So after all these checks, the first thing we want to do is set the current block that we're on to -1, indicating that we visited. Then we want to do depth first search 4 times, one for every single edge, or not every single edge, but for every single direction we can travel to, which is up, down, and left and right. So depth first search on all 4 sides, and then after all those 4 signs, those 4 method cards all resolved, we want to set our current block back to 1. Set current block back to 1. And yeah, that's our algorithm. Time complexity. I have a lot of analysis when it came to the time complexity. If you want to help clarify what it is, feel free to comment down in the comment section. But yeah, my friend and I rationalized this to be n cubed, and because we are not only doing like a grid search for the entirety of the grid until we find the one block to run depth first search on, and the depth first search by itself is also it's gonna be what's it called again? Time complexity alone of like linear time / n plus m being like that's just how depth first search is on a graph. So yeah, it would just go down to n3, but we can also say that time complexity is O of n times n. And the reason why it's n times n because the grid, as specified from the question, is not going to be like a square, but it could be a rectangle. So at worst case, however, we could be traveling through all of the blocks in the grid. So if that's the case, then our time complexity would be all the blocks that we had to visit. The space complexity would be O of h being the height of the recursive call stack, and that recursive call stack is going to be basically the size of the longest path the depth first search takes. So at worst case, then that would be n times n as well. So this would also translate to O of n times m, because at worst case, yeah, we imagine the entire grid was an island, so everything was a 1. So that recursive call stack would just be would be the size of every single block on the island, because we're doing a depth first search on every single block on this grid. So yeah, that is our approach, and we will code it up now.
To answering this question. So first, we want to create a class code variable, type int called perimeter, and this is what's going to hold our answer. It's kind of bad practice to create like a globally local scope variable, but this does make our algorithm very easy to implement. So now the first thing we want to do is set perimeter to 0, and at the end of this function, we want to return a perimeter. We won't really need this return statement. We probably won't really touch it, considering that the grid is always guaranteed to have at least one island. But just for the sake of C#, if you don't have all paths returning some value when the function is expecting to return value, there'll be a compilation warning. So yeah, now you want to do a for loop int row equals 0, and as long as row is less than grid.length, we increment row by 1 every single iteration, and then we do another for loop to traverse by column now. So column is going to start by 0 as well, as long as column is less than grid at row dot length. So this is the length of the column for every single row. So So these two for loops are going to be looking for the first instance of a island or the land, which is indicated by a 1 in this grid. So when grid at row column is equal to 1, we want to call a helper function. I'll call it find land, and in that function we want to pass in the grid and the row and column like index where we found the land at. Afterwards, we want to exit from this loop and return the perimeter. So now I'm going to create two helper functions. So I'm going to create private. This is not going to return anything. Call it find lands. Find land or just find land with no s. Okay, so this is going to take in 3 parameters. So it's going to take in a 2-dimensional array called grid. And it's also going to take in, let me make some space. It's going to take in the row and column that we are at currently. And I also want to create another helper function. It's going to return a bool, and this is what we're going to do to check if we're out of bounds for any given row or column. So I'm going to call it is out of bounds, and this is also going to take in a 2-dimensional integer grid, and then the int row and int column, indicating the part of the grid that we're at. So first we're going to check if we are out of bounds. So we pass in grid and row and column. If that's the case, that means we're at a point in the grid where there's an edge, but we don't want to like basically run a function and like try to access a part array that doesn't exist, because then we're getting error. So this is checking if we're at this point here. So when we're at this point here, we are in fact at a wall, or like we're at the edges of the land. So we want to increment the perimeter in those cases. So perimeter is going to be increased by 1, and then we return from the function. We also want to check for the case where grid, row, and column is equal to 0. Because if that's ever the case, we're at this instance where we were at the land and now we're at the water, and then we're counting these edges here because we don't want to count the water itself. So yeah, in these cases here, we are going to increment the parameter. So perimeter is going to be incremented by 1, and then again we return the function here. And then finally, one more case to make sure we don't get into an infinite loop, and to make sure we know which parts of the grid we visited and thus where we land. We want to make sure that grid at row column equaling -1 is checked. And if that's ever true, that means this part of the land has already been visited. We don't want to increment perimeter at this point. We just want to exit from the function. So now the first thing we're going to do is we're going to set grid at row column equal to -1. And that's to indicate that this is land. This is a block that we already visited. And now we want to do find land on all adjacent parts of the block. So up, down, left, and right, the 4 directions. So find land, and we're going to pass in grid, row, and column. So I'm going to put that 4 times. 2, 3, 4. And now we're going to basically just change the row and columns just so we're pointing at different blocks. So row -1 is going to be indicating the block up above us, and then column +1 is going to indicate the block to the right of us, or to the right of us. And then row +1 is the block right below us. And then finally, column -1 is going to be the block that is to the left of us. Okay. So after all these functions are called, we should get our answer. Oh yeah. And we also have to write out this function here. So we get to check if the row and column are out of bounds. So we have to make sure row. So if it's only if it's out of bounds, we want to return true if it's out of bounds, and false if we are within the grid. So if row is less than column, row is less than 0. Column, yeah, it's with 1 L. It's less than 0 as well. If row is equal actually to grid dot length, and column is equal to grid at row dot length. Then we want to return true. Else we are within the grid, so we return false. So let's run this code to make sure it runs. Okay, yeah, no errors. And that is our answer. Um, Thank you so much for watching my videos. If you have any extra things to add for the time complexity analysis, I would love to hear your input because I did have trouble with that. Um, and thank you for watching again. I'll talk to you another day. Bye.